All right, day 2, system of equations. We're going to be focusing on echelon and augmented, matrices. So, standard form of equation right here, ax plus by equals c. A, b, and c are just numbers. A and b are the coefficients of the x and y. C right there is your constant. Okay, so for example, 5x minus 8y equals negative 13. Letters on one side, constant on the other side. So number one, write it in standard form. The problem is we need everything, all letters on one side, numbers on the other. So I need to move this 9x over here. Now, it doesn't matter whether you put x first or y. Just most people put it in alphabetical order. It's kind of the understood standard form. But I also need to move this negative 6 over here. Now I'm going to move the 9 over by subtraction. So that's going to give me negative 9x. The y stays positive. And the negative 6, I'm going to have to add 6. There you go. Now, some of you might have said, well, why not just move the y over? I could have done that. It would have just been negative 6 equals 9x. I'm sorry, just move the y over. I would have had this, 9x minus y. Notice all the signs are opposite. Okay? We would have ended up, it's the same thing. It doesn't really matter. Even though they look different, it would end up the same in the end. Okay? Now, echelon form is when you have two or more equations in standard form aligned vertically. So when we just did system of equations on the previous day, and we set up those two equations, and we had, everything lined up, we had echelon form. We just didn't call it that. So for example, here, we have our x's lined up here, our y's lined up here, and our numbers, constants lined up here, echelon form. So number 2, get an echelon form. First off, we need to move this bad boy over here, and we're going to put it after the y. After the x. So that's 1/2 x. To move it over, we need to subtract 1.5y, and the negative 8 stays as it is. Over here, we need to just switch places and put the x in front of the 10y, and we need to add 4 to both sides. Okay, so we can't just move the 4 over and say 10y plus x, because they wouldn't be lined up. There's no making the x negative, because we didn't switch sides. We're just switching positions on the same side. So that stays positive, and this stays positive. The 4 changes sign because we had to add 4 to move it over to the other side. And that's it. That's the setup. Now, what's a matrix? A matrix is a rectangular arrangement of numbers enclosed in brackets. We did do a little bit of this in Algebra 2. Okay. So all it is taking those numbers from the coefficients, not this isn't the one that matches, and the constants. So for example, right here, this could have come from 4x plus 9y equals 1, and 3x plus 7y equals 0. Yes, we can have it equal to 0. We do that often. All right, where these numbers are the coefficient of x, these numbers are the coefficient of y, and these are our constants. Now, dimensions. This is very important. The dimensions are given row by column. Row by column. RC. It's got to be in that order. RC. Remote control, RC cola, whatever helps you remember, but it's RC. Now, a row, like a row of seats, goes this way. So how many rows are there? 2. Columns, like supporting columns on a building, supporting a roof, go this way. So that's a 2 by 3. Okay? Number 4. How many rows? 1, 2, 3, 4. How many columns? 1, 2, 3. That's simple. Number 5. Kind of tricky in a way. How many rows? 1. How many columns? 2. Whereas this one, kind of the flip of that one, How many rows? 1, 2, 3. How many columns? Just 1. But again, you got to be careful because calling that a 1 by 3 would be wrong. A 1 by 3 would be if you knocked this over and had something like this, 7, 4, negative 8. That's a 1 by 3. So be careful. All right, now an identity matrix has only ones and zeros, like the matrix, okay? Binary, just ones and zeros. So it's where you have ones on the diagonal, like so. So that's a 2 by 2. Here we have a 3 by 3. And if we did a 4 by 4, ones on the diagonal, and then 3 zeros here, 3 zeros here, 3 zeros here, and 3 zeros here. And you can do a 5 by 5, 6 by 6, and so forth. An augmented matrix, I've kind of already alluded to, is where you take these numbers here and put them into the matrix. So you just put your brackets, you put 4 and 3, pay attention to negatives, 12 and negative 5, 17 and 18. That's it. Now, remember though, on this one, my x, y's, and numbers were already lined up. On this one, we have to do the step we learned at the beginning. Rewrite this as 4x, positive when we move it over, plus y equals 18. At that point, we can get rid of this. Now we have it lined up, so we say 2, 8, 41, 4, this is a 1 here, 18. Now 9 is a little tricky because I have, I'll just rewrite this, 9x minus 3y equals 47. I have x, and I have negative 15, but I'm missing something right here. There is no y, but we have to put something in the matrix. If there's no y, that technically means there's 0 y's. So when we do our matrix, we're going to do 9, negative 3, 47, 1, 0, and negative 15. And that's it.